Today we'll be talking about photons and their interactions. The first one which we're covering is the photoelectric effect. Now, what is the photoelectric effect? Well, what usually happens is we have, let's say, a metal surface, or any surface is fine, and we shine some light on it. And for simplicity, we'll assume that it's monochromatic light, so it's only one color, so a single wavelength. One specific unique wavelength of light. And what we find is that electrons are actually being given off by the surface, and they are released from being connected to their atoms. And this is due to the fact that all of these photons' energies are given to the electrons. And so we lose the photons in the process. The second idea is the excited states. Namely, once again we have a surface, and it's very similar to the photoelectric effect in that our photon hits the surface and we lose the photon. However, what we find is that the energy of the photon is not enough in order to knock out the electrons from the metal's surface. So as a result, the electrons only get to higher energy states in the atom itself. So these are called excited states. The third one is called the Compton Effect. Which proved to be a good example for supporting the particle theory of light. Now, what the Compton Effect said was that, let's say we have a photon, and it hits an electron that is at rest. Now, the electron is going to start moving, and it's going to gain some energy. But what we also find is that there is going to be some light that is also given off as a result of this collision. So this is a photon, and the angle between the original path of the photon and the scattered photon, we'll call this phi. What we find is that the wavelength actually changes from the original wavelength to the new wavelength. Now, what we find is that the new wavelength is equal to the original wavelength plus h, which is Planck's constant, divided by m0c, where this is the rest mass of the electron, and c is the speed of light, times 1 minus cosine of phi. So what we find is that cosine of phi, the other way around. What we find is that the new wavelength actually gets longer. So this gets longer, which makes sense because we say that as a result of this collision, the electron has some of the energy. So the electron gets some energy, has energy as a result of the collision. And so the original energy of the photon must decrease. So its wavelength will increase since energy decreases, and since energy is equal to hf for a single photon, this is also equal to hc over lambda. So we find that wavelength and energy are inversely proportional, and as a result we have a longer wavelength. And this showed that instead of being a wave in which the energy would simply disappear, since it would all be given to the electron, we find that under this particle theory, a photon is actually still given off, the scattered photon. Now, the fourth and final way is the possibility of pair production. Now, in pair production, we start off with a single photon, and it disappears at this point, we'll call x, and it creates both a positron and an electron. Now, an electron and positron have the same mass, so this is our positron, and this is our electron. And what we find is that they have the same mass, but the only difference is they have different charge. And what we find is that the reverse is true, which is if we have a positron and an electron and they collide with each other at some point y, we find that we're going to have a photon that is created. Now, this is interesting because originally we have two objects with mass, namely the positron and electron, and when they come together, they annihilate each other and they produce a photon which has zero net mass. But their energy, comes as a result of both their mass and their speed, will create the energy of this photon. And the same idea goes for when the photon creates two objects that do have mass, since both the positron and electron have mass. So this is a matter of turning energy into mass and vice versa. So these are the main ways in which photons interact: the photoelectric effect, excited states, the Compton effect, and pair production.